Hello everybody, welcome to CodeSum again, and in this video we will discuss about the binary tree inversion. So before diving into the coding portion, let's just discuss about what the binary tree inversion really means. So at first you can see my cursor here. At first we will look at the root node. It is 55 in this case, and it has the child nodes 45 and 65, and here is the left subtree and here is the right subtree. And while inversion, it actually means that we have to interchange the subtrees, and if there are no subtrees, then we just have to interchange the leaf nodes, and basically we don't have to interchange the null. So let's go through step by step. So at first 55 has subtrees 45 and 65, and in this case we interchange the 65 and the 45 and along with the 65. And let's go for the 65 case. In 65 previously we had 60 and 70, and after inversion we got 70 and 60. Basically you can just see those square boxes. I made a simple presentation so that you can understand fully. And then we were on 45. Then 45 previously had 40 and 50. 40 as the left child and 50 as the right child. And after inversion we got 50 and 40, and basically in all the cases the square boxes are interchanged. As you are seeing here, the square boxes are interchanged in the inverted tree. So that's the case, and we are going to perform the recursion on each subtree until we get to the null. That means until we get to the leaf node. And before diving into the coding portion, let's just discuss about the time complexity of our algorithm. Well, basically the time complexity will be big O of n in this case, because we are just visiting all those nodes. We will have the recursive function that will take the root node as its parameter, and then we will perform the recursion for the left subtree and the right subtree until we get to the null. So in this case the time complexity will be O of n. And as for the space complexity, its space complexity is going to be big O of depth of the tree, because the longest recursion that we can perform here is the depth of the tree, so that we can reach to the null nodes. And as you might know that the depth of the tree is log of n. So why depth of the tree? Why there is time space complexity of log n if we are performing the recursion? Because there are maximum of d calls, that means depth of the tree, that number of calls stored in our recursion stack during the process of calling. So that's the case. So that's why the space complexity of is O of depth of the tree. So we already knew and discussed about the time and space complexity. Then it's time to dive right into the coding portion. So I will start by declaring a node, and the node will have init. Basically it's a constructor, as you might know, self, and it has data, and then it will have self dot data equals data, and then self dot left equals left, and self dot right equals right. So I will declare left as none and right as none. Yeah, then I'm going to let's go to the main section and just create our nodes. And just to be clear, I'm creating just a simple binary tree here. I'm not creating a binary sort tree, so I can take the nodes values whatever I want. So that's the case. Then I will just initialize the class, and as I initialize the class, then the constructor is called, then just I have to give, no, it's small n node, the root node, let's give 5, and then root node dot left equals let's give 20 or something. Then root node dot right equals node of, let's give 25. So basically we made the tree, and our tree will look like, let's give a simple walkthrough, 5, and then in left we will have 20, and then we will have 25. So let me comment this. Yes, done. 5, 20 and 25. This, our tree will look like this. And let me just insert another 2 values just to left and right of 20. Let me give root node dot left of left node. Let me give 10. So we then got here 10. Yeah, this will be the simple binary tree that we will invert. So, but how will we know that our tree is inverted? So for that, let me write a simple traversal function that will give me the in order traversal. In order traversal. Just to be clear, I'm not yet to the inverting tree portion, so I'm just doing the basic requirements. Let me give a node. We will recursively do this. If node is none, then we will just return, and then I will call this in order traversal method. In order traversal method for, let's say, node dot left, and then I will print that left node after calling. Then I will just write print node dot left in order traversal if node is none. So I don't need class here, node dot left, and then I will call that for the right portion, node dot right. Yeah, this looks good. Let's just check it by calling here. Let me just call right below here, in order traversal, and then we will give the root node here. In our case, the root node is 5. Then I will just give the class instance or the object. So then let's call it in order traversal dot root node left and right. What's the problem here? I'm just getting the non value here. If node is non return, in order to traversal for node that left, oh no, I just printed node that left. I have to print the data. Yeah, then yeah, we got 10, 20, 5, 25. Is that correct? We just go like this: 10, 20, 5, and 25. 10, 25, and 25. Yeah, that's correct. So let's just write the main function. The main purpose of this tutorial: invert binary tree, and we will just give the root node. Oh, then it's the same. If node is null, or let's say node is none, then I will just return. This will return one side it's the child nodes or the null nodes. No, leaf nodes or the null nodes after that. And then I will just swap the left and the right. So for that in Python we can do like node left and node right equals to node right and node left. If you are in other languages like C and C++, then you can just use the temp variables here. Yeah, this will work for me. So then I will call the invert function. I will call the invert binary tree function for the left portion, and then for the right portion, no, the right. So let me explain here a bit. First, I gave it the root node. Here our node will be the root node 5, and then once then it will just if node is done, our node won't be none at first, then it won't return, so it will go in this portion, and then it will try to swap our left and the right, like 20 and the 25 along with the 10, yes, and then it will call the left portion recursively and the right portion recursively, and once it reaches the null node on 10 and 25, then it will just return and our recursion will stop. So let's just so first I will write the inverted tree. What's our inverted tree will look like? Inverted tree, it will just look like 5 and then 25 and then 20 and then our 25 and then 20th right child will be 10 basically. Then I will just comment it. Then I will just call the traversal function so that I can prove you, or you will understand clearly. In order traversal method, yeah, I will call right here. So let me just print after inverting traversals result after inverting the tree. Yeah, in order traversal, then just we will pass the root node. Yeah, this looks good. So our answer must be after inversion. We must get 25 and then 5 and then 20 and then 10. Let's run it. 10, 25, 25. Though it's not working. Let me see. Oh, no, I didn't call the, I understand, I didn't call this particular inversion function, so I have to call the inversion function here first. Invert binary tree, then I have to give the root node. Yeah, now it should work. 10, 20. Then after inversion our answer will be yes, 25 and 5 and then 20 and 10. 25 and then 5 and 20 and then 10. Yeah, finally our tree is inverted. So this much for this video, guys. I will see you in the next one, and if you are interested in this kind of stuffs, then you can consider subscribing the channel, and then I will keep posting this type of interesting videos once a week or twice a week. So then bye bye.